Hello, Math 30-1. Welcome to a new unit on um, logarithmic and exponential functions, a very, very practical unit. An overview of this unit is just going to be talking about the relationship between logs and exponential functions and an introduction into the product quotient and power laws of logs. There are many practical real-world applications that involve exponential and logarithmic functions, and we're going to solve a lot of those problems. The first thing you need to have is a real good grounding in exponent laws. If you can't do exponent laws, you are never going to be able to be successful with logarithmic laws. So I want you to review these laws and remember that, as we see here, that the entire part of this is called the power. The words we use are very important. Excuse me, the n is the exponent and x is the base. I want you to complete the following exponent laws and then come back and look when you're done. As you look at the laws that we say, it's really important that we use these properly, that when we have a product law, we add the exponents if they have the same base. If we have a quotient law, we subtract the exponents if we have the same base and we're dividing. The power of a power, we multiply exponents. Power of a quotient, we distribute that exponent to both. A negative exponent means that that power is misplaced, that it must be moved to the bottom or the top depending on where it belongs. And we can see this example over here, that if we have x2, y minus 3 and z minus 2 on the bottom, that these two must change places. That z power is not happy, and this power of y is not happy, and they exchange places top to bottom. And lastly, rational exponents. We've talked about that from Math 10. And the denominator of a rational exponent is the index number of a radical, and the numerator is the exponent, right? We need to use those in a proper way. And when in doubt, as we talked about in Math 10, when in doubt, expand it out. So if you're in doubt about how a power works, just expand it out, and we know that x to the 3 is equal to x times x times x. So if you have to use repeated multiplication, we can. We don't have to use exponent laws, especially if we're going to misuse them, all right? So let's complete the following questions. And so if I have 1/2, we want to simplify with only using positive exponents. So in this case, I have 1/2, and this is going to be y to the 6 on the bottom, and therefore we get 1 over 2y to the 6. In question B, I have two powers that are not happy, so I put the y squared to the top, and the x to the 3 goes to the bottom. In the next example, I will worry about positive and negative at the end. I will use my multiplication law, and I get 4 times 2 is 8, x to the minus 1, and y to the 3. But I can't leave it like that because I must rewrite it with positive exponents, so the y cubed stays on top and the x to the 1 goes on the bottom. Carrying on, we simply use division, and 24 divided by minus 4 is minus 6, m to the 1, p to the, careful, minus 2, minus 3 is minus 5, and q to the 6, 4 minus minus 2 is 6. Again, this 6 is fine, it's just a negative integer. You don't move that. The m stays and the q6 stays, but I must put the 5 p's to the bottom. E, be careful with coefficients. And again, you should be doing these first and then coming to check them after. 3 cubed is 27, and x to the 6 and y to the 9. Be careful how you do your exponent laws. 12 divided by 3 is 4, and b to the minus 1/2 minus another 1, 4b to the minus 3/2, which we can't leave like that. We put b to the 3/2 in the bottom. All right, so those are the basic rules, and now you carry on and simplify some, I suppose, trickier questions. Remember that negative numbers have always been negative numbers, and a minus 3 just stays minus 3. And if you had a minus 3x to the minus 2, the minus 3 would simply stay on top, but the x to the minus 2 would go to the bottom, right? So be careful when you're dealing with negative coefficients versus negative exponents. So in the first step here, when I distribute that exponent of minus 3, I get 4 to the minus 3, x to the minus 3, and y to the 6. So clearly, I have to write answers with positive exponents and simplify it. Clearly, as I simplify that, I have y to the 6 on top, and I have 64x cubed in the bottom. In question B, it makes sense for me to, why don't I just flip this over? I've got a negative exponent. Why don't I turn the whole thing over first? And I would have 4y minus 2 on the top. I'm getting rid of that negative there. And I would have 3x cubed on the bottom. Notice I didn't change the negative exponent on the y because I was only dealing with the negative on the outside first. When I multiply through with that exponent, I end up with, I end up with 16y to the minus 4 all over 9x to the 6. And I finish the question off by getting all my exponents in positive places. So I have 16 over 9, x6, y4 as my final answer. All right. And again, without using a calculator, determine the exact value of this and verify with the calculator if you have to. But 2 to the minus 3, that's just 1 over 8. And the fourth root of 81 to the 3, that's just going to be 3 to the 3, which is 27. 25 to the 0, that's 1. And 1 over 16 to the half, which is equal to the square root of 16 is equal to 1/4. All right, we don't need calculators for that, right? Changing of a base. This is going to be a big part of our travels. So if you want a base of 3, what they're saying is we don't want this 9, we want a 3. But we know that 3 squared is really equal to 9, so it's 3 squared to the 2x, which with exponent laws would be 3 to the 4x. I've got 125, but that needs to be a base of 5, so that's going to be 5 cubed to the 2 minus x. That gives me, when I use my exponent laws, 5 to the 6 minus 3x. We have to change all of this to a base of 2. So both the 16 and the 8 have to be changed to a base of 2. Well, that's not bad. 8 is 2 to the 3 times 16 is 2 to the 4, all to the x. I use my exponent laws and I get 2 to the 4x plus 3, because obviously I add exponents when I'm multiplying things with the same base, right? And we clearly can't do this question. You would step in a whole bucket of wrong if you tried to do something like multiply these numbers together. This would be bad if you said, well, I'll just go, Mr. K, would be a lot faster if I just went 8 times 16, which would give us something like, so if we chose to go 8 times 16 to the x, we'd clearly get 128 to the x, which is nowhere near what we actually get as our final answer. I think 128 is 2 to the 7, so we would get 2 to the 7x, and that is definitely wrong. You cannot multiply things when they don't have the same base, right? So we can't do that. Carrying on with our base of 2, 512 is, I believe, 2 to the 9. And so 1 over 2 to the 9, that's still to the 3x, is going to be equal 1 over 2 to the 27x. Now it says to convert the following. Some books might rewrite this as, well, we want a base of 2, and technically this is on the bottom, so they might write the answer in the back as, they might write the answer in the back as 2 to the minus 27x, just because they want that brought to the top. And in this question, we want a base of 2/3, so 2 over 3 to the 4 gives me 16 over 81, all to the x plus 5. So again, we distribute that inside, and we get 2/3 to the 4x plus 20. All right, now you can rattle off questions 4 to 5. We carry on, and there's some examples that we can look at here. So sometimes, and this is an important note, sometimes we have to, sometimes we actually have to, um, no, we can't express things as the same base. So in this case, you use the following procedure where you have an irrational exponent and you're trying to solve for the base, right? So in this case, we have an exponent of -4/3, but we really want is just x equals our number to make us happy. How do we blow up that -4/3? Well, the answer is you simply do the opposite. You've got -4/3 there, so if I was simply to put this all to a fraction of -3/4, when we multiply these two exponents together, we simply get x to the 1. And now I've got the fourth root of 81 to the -3. And the fourth root of 81 is 3. 3 to the -3 is 1/27. So our answer works out to a nice 1/27. And in this example here, we use that same idea. If I want to blow up that 3/2, I simply raise it to an exponent of 2/3. When I do that, I get 3x minus 5 to the 1. Those two fractions multiply and blow each other up. The cube root of 27 all to the 2 gives me 3x minus 5 to the, whoopsie, we forgot to put a cube there. Cube root of 27 to 2 equals 9, so that means that 3x is equal to 14, and that means that x is equal to 14/3. And all was good in the land. All right, so now you're able to finish this assignment, and that is good. Lesson 1 is done.